Let's go ahead and get started. So first, we're gonna identify image 1 and image 2. This is what you see on a periodic table. So the top number is atomic number, which is also the number of proton. Okay, the smaller number, atomic number. The other number is mass. In this case, they are average atomic mass. Okay, and then this is a symbol. Again, same thing. I just abbreviate average. Atomic mass. Here, you'll see that both plus and plus here, the blue one, that's proton. The one with no charge are neutron. Proton and neutron together are called nucleus. And the little thing, the negative charge particle that's circling around, that's electron. All right. Proton usually symbolize P plus, and then neutron N0, and then electron E minus. Location, these two are in nucleus. This one is outside. You can say surround the nucleus. Charge, like I said, this is plus, this is no charge, and this is minus. This is approximately 1. This is also approximately 1 AMU. They both has about mass. This is approximately 0 AMU. By the way, these are squiggly line, which mean approximately, right? Not equal to or the negative sign. This is approximate sign. All right. Image in element 1. So if you look at the element 1 right here, you'll see that it has atomic number, which is 1. That's a number of proton. We're assuming that these are elements, which mean the charge is neutral. So that means proton and electron number in the neutral atom must be the same. Okay. Mass, since remember that proton and neutron has approximately mass of 1 and electron has 0, the mass must be made out of proton plus neutron. So for that reason, for the image number 1, it has 1 protons, electron, also 1. For the neutron, it's going to be 0. The reason neutron is 0 is because neutron is mass minus proton. Okay, that's how you find it. All right, image 2, let's go ahead and do that. Protons, that's 13. Be careful, it's not 27, it's 13, the smaller number. Electrons also 13. And neutron, in that case, you would do 27 minus 13. So that would be 14 neutron. Last one, image 3, that's very easy. You can just count the plus, minus, and the green no charge particle. So blue plus 1 is 3, and then electron, that's a red little negative dot, those are 3 also, and then neutron, in this case, 2. So what element is? So you need to look in a periodic table to find the elements with 3 protons. So you're gonna look for atomic number 3. So the top number, take a look at it, and you will see that that will be lithium. Okay, so that's what we're at in this case. And lithium symbol is Li. Oops, I write I and U at the same place. Let me rewrite that. Oh no. Also Li. Okay. Periodic tables, let's look for element 3. So if you look in a periodic table, Li has 3 on the top, and then depend on the table that you look, well, actually they both should be the same. So you should get 6.94 on the bottom. We're gonna approximate it at 7. So based on that, we're gonna say protons is 3, electron is also 3. For a neutron, like I said, we're gonna approximate that, that's 7 minus 3, so we're gonna say 4. Okay, what's the difference between the elements in above in 3C, right? So that is basically trying to yeah, I should probably reword this question. I want you to compare this with this, basically. So what is difference in that? So you will see that right, image 3 lithium is different from lithium in periodic table, and the main thing is different number of neutron, different mass. All right, how do you find the mass of atom given the amount of subatomic particles that make up an atom? So again, I just said mass is equal to proton plus neutron. Neutral atom will have the same amount of H2 particle. That would be protons equal electron in neutral atom. Okay, not in the iron. We'll talk about iron on Monday. All right. What is the one thing that determines the identity of the atom? That is the protons. Protons show you what element it is. Okay, that's always proton. Define atomic number, atomic mass, and isotope. I would say atomic number equal number of protons. Atomic mass equal number of, I'm not gonna write off, just gonna say that, of protons plus number of neutron. Isotope, actually, I don't know why I do that. It's not bracket, it's just space. Same element, same number of protons, different number of neutron, different mass. Okay, yellow period table, you should be able to know these. For AP purposes, you don't necessarily have to know like specific like alkaline or metal, halogens, normal gas. Plus, you will remember them as we work on these, just like how you don't have to memorize elements name and the formula symbols, you will get used to them and you'll remember them. So for now, use the periodic table because that's there for you to use. Okay. C is carbon. Atomic number is a not number, that's 6. Remember, this number is the same thing as that number as this number. So this will be 6 and this will be also 6. Atomic weight based on the periodic table is about 12.01. We're gonna approximate 12. Okay, so for neutron, it is mass minus proton. So 12 minus 6, that's 6. All right, next one, Br, bromide. That is 35, which means this is also 35, and this is also 35. The number atomic weight is 79.90, so approximately 80. So I would do 80 minus 35, so that would be, oops, What am I typing? That would be 45 right there. Okay, Mg, be careful with that one. That is magnesium. Which has an atomic number of 12, which means protons 12, electrons 12. Mass is about 24.31, so about 24 minus 12 is 12. Mn, that's different one, that's a manganese. Okay, that one is 25. And its mass is 54.94, so about 55. So 55 minus 25, 3. All right, I is iodine. $53. So 53, 126.90, which means 127 minus 53. So we'll get 74. Okay, I would probably ask you to pause it and then do the rest of the table if you haven't done it yet, and then check the answers. All right, I'm just gonna continue. Yeah, 10, 10, 10. Oop. That's a 1. Helium. 2, 4. Oh, that should be 10, not 0. Calcium. Sulfur. Okay, Be, beryllium. Oxygen. Lead. Boron. Aluminum, or you can say aluminium. Aluminum. All right, now let's do the bottom one. For the bottom one, be careful with that is don't use the mass from the periodic table to tell because they are isotopes. So that means you're gonna see a few of the same element. For example, you already see here, hydrogen, hydrogen. So since they're both hydrogen, you know that the atomic number is 1. and 1. Their proton is 1, electron is 1. You know these. What you don't know is their other information. So you can see since mass is 1, this neutron is 0. Now see, since this neutron is 2, the mass here is 3. Now how does that go? Remember, mass equal proton plus neutron. Okay, that's what is going on there. And then of course, remember, neutron equal mass minus protons. Remember that. All right, let's continue. Carbons, so that should be 6. And since this is 12, they're all 6. We're good. 8, that's oxygen. Okay, that's a Y. Okay, since neutrons 8 too, this is 16. All right, let's see. This is hard because you don't have the atomic number or name, but remember, proton is the atomic number, so that's 6, which means this is carbon, which means these two are isotopes. Okay, nitrogen is 7. Okay, this is 7 because 14 minus 7. All right, let's see. Neutron is 2, mass is 2. Neutron is 1, mass is 2. That means proton is 1. Since proton is 1, electron is 1. That means this is 1. If this is 1, this is hydrogen. Ooh. So you will see we have 3 hydrogen isotopes. They each either having 1 neutron, 2 neutron, or 0 neutron. So they have a different mass, either a mass of 1, 3, or 2. But you'll see that the atomic number is the same. And proton and electron are the same. Okay, let's see. Let's just get rid of those marks. It's harder to print out later. All right, go back to this. Cesium. Cesium. 55. Okay, so we need to do 55 plus 82. 137. Okay, 11. Sodium. Okay, 11. 11 plus 12, 23. Yeah, okay. Please let me know if my math ever happening here. For the most part, it should not, but trying to do something there. Okay, so that is 47 element. That is silver. Hey, this one's mystery. Mass is 80, neutron is 45. So that's a 35. Who is at 35? Let's see, bromine. Okay. Not sure why this part doesn't write. Okay. This one is 24. So that would be chromium. So that would be chromium. Uh, 52. So that would be 28. This is silver. 17 minus 47, because silver is a 47. So that would be, hold on. No, why is it 47? 60. So you can see that there's a few isotopes. Like I said, there is 3 hydrogen isotope going on here. There is isotope of carbon. There's an isotope of silver. This is different from the silver. Right, so there's some isotopes in here. All right, round for suffix. Didn't really tell you guys, but the way that suffix counting, I teach you guys the box method, but it's another method, is with the rule. So pretty much the rule is this. 0 in the front is never significance. Non-zero number is significance. 0 that is sandwiched between the non-zero number are significance. Now, for the 0 at the end, the trailing 0, they are significance if there is a decimal somewhere in the number. So that was the rule. Again, the rules are 0 in the front is never significance. Now, let's talk about always. Non-zero number are always significant. 0 sandwich in between non-zero number are always significance. Okay, now sometimes things 0 at the end, they are only significance if there is a decimal somewhere in the number. So for that reason, the easiest way to do is the box method. So I'm gonna quickly highlight through them. So I like to do non-zero number, right? Non-zero number, and all the sandwich 0 also counted, right? So you can see that non-zero number plus sandwich 0, right? Try not to get all of them. Okay, for the most part, you will see that they don't have a 0 at the end, then we're good to go. But let's talk about the one with the 0 at the end. The one with the 0 at the end, we just have to look for the decimal. If there is a decimal, let's go ahead and count it. So you see there's a little decimal, so that means we count it. This doesn't count, this doesn't need it. There's a decimal there, so we count it. That doesn't need it, nope. There's a decimal there, count it. No need it, no need it. Decimal there, we count it. Decimal right there, so we count it. That's it. Now we're just gonna write down how many is in there. So we say 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a lot. 1, 2, 3, 4, 5, 4, 6, 8. 1, 2, 6, 7, 3, 4. 7, 5, 6, 5, 5, 6, 8. This is the 8. Yes. Okay. I just rewrite it. All right. Now what we're gonna do is we're gonna round to the 3 significance figure. So 3 significant figure. Look at the first 3 significant number, and then the number after that. So first 3 significant figure, these 3, right? 2, 0, 1, and then the next number happen to be 3. So you round down. So therefore, you're just gonna be 2, 0, 1. And then of course, you gotta replace the rest with 0, 0, zeros to keep it the same variable. Right? You don't want to change a variable. All right, let me just kind of run through these. Again, if you need to, I will pause it and then come back to it. Right, pause it and try doing this. Oh, by the way, you could put a comma to separate these. So for example, like this, every 3, you can put a comma. Now, be careful. Comma and period are two different things. So make sure you don't get confused. Okay, so if you really want to, I can put a comma there. But however, you cannot put period there. This is where the handwriting kind of come in. Yes, I know Michelle don't have the best handwriting either, but you know, and also for the decimal, be clear a little bit so that the reader don't get confused. And like I said, I just do every 3 just so that I can see it better, right? By the way, if you want to write them in a scientific notation, you are free to do. So for example, this D, if you want to write in the scientific notation for rounding, that's become 5.79 times 10 to the, let's see, 8. Okay. However, not required. Oh no. Right, this one's kind of hard. You can just underline this, or you can write it into this notation, 6.00 times 10 to the 3. Okay, either one's fine. Okay, I'm not gonna go ahead and write the rule for rounding. Basically, when you are multiplying, you check the significance figure. Multiplying and dividing, you check the significant figure and then use a lower significant figure. When you're adding or subtracting, you check the decimal. Okay, that's pretty much what the rule is. So basically what we're saying is over here. So you'll see that when you're multiplying, you're gonna go ahead and multiply it just the regular way. Times 14. I'm gonna get this as 327.6. Okay. Now how do we round it? Remember, the way that we round it, you have to think about it, the significant figure. So you see this one has 2 suffix, this one has 3 suffix. So your answer should be in 2 significance figure. Okay. So how do we do 2 significant figure? Well, you round it. Oops. So the next number that you're looking for in this case is a 7. So you round up. So therefore, this is going to be 330. Okay. There you go. That's a 0. All right. Now, how about this one? This one, adding and subtracting, you got to set it up. Or you count decimal place. It's easy, right? I'm going to cut it off right here. So let's see, what's subtracting? So 27.68 minus 14.369. So that gave me 13.311. Okay, so that's what we're getting. So what you're gonna do? Round it. So since this is 1, you round down. So therefore, this is just 13.31. Okay. All right. Let me pause the video because I don't want it to go forever. So these are the answers to the rest of them. So let's work on some of the unit conversion. So for the unit conversion, use the unit conversion sheet. I would prefer you show me the word, whether what you type in the calculator or how you set it up. So those are important. Okay, let's go ahead and run through one. So you got, oops, you have 250 grams, right? So what you want to know is I want to at least want you to write these units so that you can show me that unit cancel out. So this is a unit that we don't want, so that will go down on bottom. The unit that you want go on the top. So in this case, you want to look in equation sheet to see can grams go to kilogram, and it does. So therefore, you can just write it there because 1 kilogram is 1,000 grams. So in this case, you're just basically dividing it, and you will see that that will give you 0.25 kilogram. You can say 0.25 or 0.25. Either way, that is the same thing. All right, next one, 0.030 kilogram. Again, we don't want a kilogram, so kilogram go on the bottom, gram go on the top. In this case, 1 kilogram, 1,000 grams. So you're multiplying. So you will see it is gonna to give me 30 gram. And then, you will say this is only one suffix. To make it two suffix, put a dot there, right? Let me do something that you might have a few steps. Well, do somewhere down here. Okay, so moles of electrons, 1 coulomb. So you will see that I give you an equation for you to use. Okay, so we're gonna use that equation here to do. Okay, so we're gonna start with this 2.5 mole electron. Now remember, we don't want that, so that's go on the bottom. And then what we want on the top, which is coulomb. Okay, so that's 1 mole. That's 96485. What you do, you're just basically multiplying it because they're both on the top. So the key to that is I want you to show me that the unit will cancel out so that you get the unit that you're looking for. Okay, 96485 times 2.5, we're gonna get okay, 241,212.5. So we're not gonna write all that because we want to do two suffix. So I want to say 24000. Let's see, hold on. 1, 2, 3, 4. I need one more 0. 0. So we should be good. Okay. You can, I'm gonna write the rest and pause the video because actually I want to do a few more on the screen. 537 millimeter. We don't want a millimeter, go on bottom. Millimeter is gonna go to meter. So what is this gonna to be? 1 meter, 1,000. Oops, I have a really bad writing. 1,000 millimeter, and then 1,000 meter, 1 kilometer. Okay, so you can see unit cancel off, right? And then we get kilometer. So in this case, you're dividing and then dividing it. So if you want to write a usual one, it will be 0.000537, right? Let's see, let me just double check that I'm typing it correctly. I didn't type it correctly, so that's good. All right. Okay, seconds to hours. 4 seconds. Seconds, I'm gonna go to minute, 1 minute, 60 seconds. Okay, 1 hour, 60 minutes. Right. Can you go directly and say 3,600? You could. Okay, just showing you how the unit will cancel out. So that would be 2.5 7, 5, and then 6, 6, 6, 6, 6. So we're gonna round it. Oh wait. Okay. Moles to calorie. Okay. 930 millimeter mercury. Millimeter mercury. We're gonna go to ATM first. Okay, that is 1 ATM 760. And then we're gonna do ATM 2 kilopascal. Okay, again, unit cancel out. I don't do that all the time, but it's a good habit to cross out the unit and double check that you are actually gonna get the unit that you want. So 1, 2, 0. Approximately, that would be really tricky to write because two suffix, if you want to do two suffix, you can say this with a thing, or I'm gonna use a scientific notation. 1.0 times 10 to the 3. Okay. Or this. Okay. All right. Meter to nanometer. So this is a 10 to the negative part. Time 10 to the negative 5 meter. 1 meter. Oops. Let me write it. Meter. This is going to be 10. If you guys know, this would be 10 to the 9, or you can have all the zeros, basically. So it's either 10 to the 9, or you can say 1, 2, 3, 4, 5, 6, 7, 8, 9 nanometer. Okay. For this one, is very, very crucial, important that you are typing it correctly into your calculator. By the way, I didn't write it correctly. That should be negative 15. See, already did not writing correctly. So yeah, make sure you're writing them correctly. Otherwise, it gets slightly tricky. Okay, these two are you're not adding. You're not multiplying or dividing. You're adding and subtracting because Kevin is the Celsius plus 273.14. I'm just gonna keep it at 273 or 270.14. This is actually fine. You can just use it. So we're gonna go with that. So if you round this based on the suffix, you're gonna get 297. This one is 1.6 fixed, so it will be slightly different. So we're gonna keep it 1 decimal place for this one. So 269.6. All right, that's pretty much it.